Hello. Our next topic is page tables or memory map table MMP. So as we have discussed in process management, process table were there. Process table was to keep track of which process to keep track of all the running process and status of running processes, right? So similarly here we are having uh, page table to keep track of each and every page frame in your physical memory. So whenever a process requests for a page frame, the operating system first locate a free page frame in the memory and then allocate it to the requesting process. So for that, operating system must have some track of each and every page frame in physical memory. So to keep track of page frames, there is page table, or you can say memory map table, right? Now for this, the OS must keep track of free and allocated page frames in physical memory. One way to achieve this is to maintain a page table. So we can say per page frame there is one entry. So for example, your physical memory having 8 page frames, then 8 different entries in your page table. Per page frame, there is one entry, and that entry indicates everything or status of your page frame. Thus, the purpose of page table is to map virtual pages onto page frames. So we have already seen the memory map table. That is, we are discussing, right? How memory map table it contains which kind of fields. So, thus the purpose of page table is to map virtual pages onto page frames. So, mathematically, the page table is a function with the virtual page number as argument and the physical page frame number as a result. So so whenever your CPU generated address will send to the MMU will convert your virtual address into physical address using this MMP, this memory map table or a page table. So, a page table is structured in the form of static table in which each entry describes the status of page frame, indicating whether it is free or allocated. Hence, a page table for a given system contains only as many entries as there are number of page frames in physical memory. So, structure of page table entry. So now means we were talking about page table. Now let us discuss in detail one entry, single entry of that page table. So it contains which kind of fields. So actually it is machine dependent. Fields may vary from machine to machine. But here we are discussing some common fields which are used in each and every machine, right? So let us discuss detailed single page table entry. So a single page table entry, we can see figure 3.15 and 32-bit computer. Size varies from computer to computer, but 32-bit is the common size. So in this entry, we are having this many informations like caching disabled, referenced bit, modified bit, protection bit, present absent bit, page frame numbers. Now let us discuss one by one each and every field in detail. So what is the meaning of particular bit? So suppose your page table entry, single page table entry of 32 bits, then each and every bit indicates something. So let us try to understand. First field in page table entry is the most important field, page frame number. After all, the goal of page mapping is to output this value. So for particular page, which page frame number, means for which virtual page is mapped with which page frame number. So we required page frame number whenever we want to convert our virtual address into physical address, right? So one of the field in page table entry is page frame number. Another is next to it, we have the present absent bit. If this bit is 1, the entry is valid and can be used. If it is 0, the virtual page to which the entry belongs is not currently in main memory. So present absent bit indicates whether a particular page, virtual page, is in main memory or not. If bit is 1, it means entry is valid, so our required page is in main memory. But if it is 0, then it indicates current page is not in memory, so there is page fault, so call to the OS or trap to the OS, and further actions will be taken by operating system, that is page replacement, by using any page replacement algorithms that we'll discuss later on in detail. Okay, so the protection bit next is protection bit indicates which kind of you can say permission or access is given for particular page. For example, suppose this field contains 1 bit, right? So bit may be either 0 or 1. So if it is 0, it means you can read and write that page, right? But it is 1, bit is 1, it means read only, permission. For more sophisticated arrangements, there may be 3 bits, 3 protection bits. 3 protection bits, one indicates enabling reading, second indicate writing, and third indicate executing. Means 111, then reading, writing, and executing. Permission for that particular page. Suppose 101, it means reading, no writing, and executing. Permission is there, right? And so on. Then the modified and referenced bit. So let us understand what is the meaning of modified bit. So whenever your virtual page you are putting in physical memory, main memory, right? Then there are some operations as we have discussed, read, write, or execution may happen with that page, right? So it may happen we have performed write operation, then there are some changes or we have modified that page. So modified bit indicates whether particular page is modified or not. If 1, it means page is modified, so put updated copy onto the disk. So you can say that is your page is dirty, right? It means modified. But if it is 0, it means page is not modified. So content is same as disk copy. So there is no need to rewrite onto the disk or copy onto the disk. So sometimes this bit is also called dirty bit, right? So this theory is important. Explain page table, or you can say each and every field in detail of page table, right? The next bit is reference bit, and reference bit is that whenever a page is referenced either for reading or writing, its value is to help the OS choose a page to evict when page fault occurs. As we have discussed earlier, whenever page fault occurs, then call to the OS. OS will identify by using any page replacement algorithm, identify the least used page and try to evict that page from the page frames, and so page frame becomes free for new page, right, that we want to execute. So at the time of page fault, referenced bit is very useful, and this bit is used in some of the page replacement algorithm to take the decision about which page will be evicted, right? So the page table hold only that information the hardware needs to translate a virtual address to a physical address. So for that conversion, a page table, or you can say memory map table, is used. And we have discussed the each and every field in detail. Okay. The next is speeding up page.